Hey everyone, welcome to Brain Attic. Today we are going to see a very simple RLC circuit. We all know that RLC circuit is very important and has various applications across different domains. But also, while giving an interview for a VLSI industry, the interviewers are often interested in seeing your approach while solving such problems. They give you a problem not anticipating that you will give a definitive answer, but they are more interested in the kind of approach you are taking to it. So let's begin. Here in this problem, we have a simple RLC circuit where the inductance, resistance, and the capacitance are all parallel to each other. The value of the inductor is 5 Henry, resistance is of 8 ohm, and the capacitance is of 12.5 millifarad. The initial voltage across the capacitor is given to us, which is 40 volt. Since they are parallel, the 40 volt is the initial voltage across all the elements. Now we are asked to find Vt if the initial inductance current is 8 ampere, and in the second part of the problem we are asked to find current It if the initial capacitance current is given as 8 ampere. So let us begin solving this problem. We first try to find the Napier frequency. The Napier frequency is given by alpha, which is nothing but equal to 2 by RC. Now applying the values, which is 2 into 8 into 12.5 into 10 power minus 3, we get 5. And we then find the resonant frequency, which is given as omega naught and is equal to 1 by root over LC. We apply the values and we see 5 into 12.5 into 10 power minus 3, which is nothing but equal to 4. As we can see that alpha square is greater than omega naught square, then the response is overdamped. Response is overdamped. When the response is overdamped, we know the relation that Vt can be written as A1 e power S1t plus A2 e power S2t, where S1 is equal to minus alpha plus alpha square minus omega naught square. If we put the values, we see minus 2, and S2 is equal to minus alpha square minus omega naught square. Applying the values, we find minus 8. So we know that our Vt is equal to A1 e power minus 2t plus A2 e power minus 8t. Now we need to find the values for A1 and A2, and this we can do with the initial conditions. So V0 is equal to A1 plus A2. We know that V0 is equal to 40, so A1 plus A2 is equal to 40. Now we mark this equation as equation 1, and we mark this equation as equation 2. Now we find the derivative dvt of dt with respect to time at t is equal to 0. This is nothing but equal to minus 2a1 minus 8a2. Now we know that IC can be given as C dv dt. Okay, using whatever equation 3 which we derived, we put the value of dv dt at t is equal to 0. We can write it as 1 by C current IC at 0. So this we know is 1 by C minus IL0 minus IR0 plus. Okay. Now putting the value of the capacitance, which is 12.5 millifarad, and we know IL0 is equal to 8, and the current can be given as 40 by 8, that is VR by R. There's a mistake here, these are possible. So what we are left with, there's a mistake, these this is negative. We are left with 1040. So we finally have minus 2a1 minus 8a2 is equal to 1040. Simplifying this, we have a1 plus 4a2 is equal to minus plus 5020. Now if we solve for both the values of both the equations which we have, what we are left with is a1 is equal to minus 120 and a2 is equal to 160. So we have our VT equation, which is minus 120 e per minus 2t plus 160 e per minus 8t. Now we solve the second part of the problem. Here we are given that IC0 plus is 8 ampere. Now the current response can also be written as current response for the overdamped system which we have is given as IT is equal to A1 e power S1t plus A2 e power S2t. We have already solved for S1 and S2 and we know that IT is equal to A1 e power minus 2t plus A2 e power minus 8t. Now IC0 we put the value 0 here, so we have A1 plus A2. Now IL 0 positive is equal to minus of IR 0 plus IC 0 positive just after 0. This can be given as V0 positive by R, the same thing, plus 8, which is nothing but equal to minus 13. V0 40 and R is 8, so 5 plus 8 13. Now we have A1 plus A2 is equal to minus 13. We take the differentiation of the above equation di by dt if we do right. We are left with minus 2A1 e power minus 2t minus 8a2 e power minus 8t. Now this di by dt, if we evaluate it at t is equal to 0, right, we are having minus 2a1 minus 8a2. And this di by dt at t is equal to 0 can be given as L 1 by L VL0 plus 2, which is nothing but 40 by 5, which is 8. So we know that minus 2a1 minus 8a2 is equal to 8. We just simplify this a little bit more. 4a2 is equal to minus 2, minus 4. So finally, solving the equations for a1 and a2, we have a is equal to minus 16 and a2 is equal to plus 3. Therefore, the current response can be given as minus 16 e power minus 2t plus 3 e power minus 8t. If you do like this solution, please hit the like button, subscribe to our video. Thank you so much.